The OceanGate Titan Explorer submersible submarine vessel imploded at the underwater site of the Titanic shipwreck about 400 miles off the coast of Newfoundland, killing all 5 crew members. So unless you're living under a cave, by now you already know about the implosion, but you don't know what caused it, what led up to it, what was going on. Did they know that they were about to implode when it happened? So today we're going to discuss some possible root causes of what could have led to this implosion.
As all expeditions start exactly on time, I wanted to welcome everyone. We had, I think, over 400 people sign up. We've got, looks like 165 already on.
On Sunday, June 18th, 2023, around 8 a.m., Titan was disengaged from its platform and began the descent down to the Titanic. Now, according to their website, it says it takes 90 minutes. Other people have said that it takes 2 hours, and I've also seen 2.5 hours, so we don't really know. But then, an hour and 45 minutes after starting the descent, the surface vessel loses contact with the Titan. So now by 3 p.m., the Titan submarine is supposed to be back on the surface, and it's not. So now it's missing, and they report it missing. And remember, after 16 hours, the fusible links holding the weights should dissolve, and it should surface automatically. But of course, the Titan never resurfaced as far as we know.
This morning, an ROV, or remote operated vehicle, from the vessel Horizon Arctic discovered the tailcone of the Titan submersible approximately 1,600 feet from the bow of the Titanic. The debris is consistent with the catastrophic loss of the pressure change.
Now, the U.S. Navy has this system called the Integrated Undersea Surveillance System, and they can detect enemy submarines, but they detected the implosion. They heard the sound of the implosion through this system on Sunday morning. So as far as we're concerned, the military already knew these people were dead on Sunday morning. So my question here then is, why in the world did the Navy not tell us on Sunday? They could have saved everybody and all of these planes and ships and all of that trouble searching for this submarine that they knew had already imploded. It's no coincidence, in my opinion, folks, that the Coast Guard waited until the 96-hour time window ran out for all of the backup oxygen and everything to run out. As soon as that window expired, that's when they told us that they had found it. So guess what, folks? We now need to rewrite all of the history books on the Titanic shipwreck disaster to add the 5 additional names of these victims now, because they are now indirect victims of the Titanic disaster. So just like with hurricanes and tornadoes, even though they've already blown through the area, we often see people that still die related to that due to the dangerous environments. It's like the gift of death that just keeps on giving. Okay, so I'm going to mention here something here that you haven't seen on any other videos that cover this topic, the margins. Let's start off by looking at the design limits of this Titan submarine. For many years as an engineer at Motorola, I used to tell all my fellow engineers, try to design with a 50% margin. So if you're designing a circuit that has a 20-volt capacitor, this capacitor should only be operated at 10 volts. That's where you get your design margins from. If Stockton Rush wanted to operate his Titan submersible at 3,800 meters, it should have been certified to be much deeper than 3,800 meters. Now, the company claims 4,000 meters, but even then, if it's only rated at 4,000, you shouldn't be taking it down to 3,800 meters. Do you understand the situation here? So Stockton Rush, in my opinion, he sort of flirted with the event horizon of a black hole. And then he got him and his other 4 passengers sucked into this black hole. Takeaway here, folks, is that your engineering limits are not something that you want to design toward and operate toward. Those limits are something you want to run away from as fast as you can. A 4,000 meter rated sub should never be operated at 3,800 meters, in my opinion. By comparison, if you look here at James Cameron's Deep Sea Challenger, you can see right here that this was rated to go down to 16,500 pounds per square inch. And as you know, the pressure around the Titanic is about 6,000 psi. And then also, if you look at the MER submersibles, which you might recognize from the Titanic movie, and you go here and you look, here's their test depth right here. They can go down to 6,000 meters. So I would much rather go on James Cameron's Deep Sea Challenger or the MER submersibles any day before I would even consider going on the Titan, because you see those big margin gaps you have. Because remember, in order to dive the Titanic, it has to be able to make it at least to 4,000 meters, but of course you want it to be much stronger than that.
Monday morning, when I first found out about the incident, within an hour and a half, I had the following information. They were on descent, they were at 3,500 feet, they lost comms and tracking. So for them to lose comms and tracking at the same time, sub was gone. We got confirmation within an hour that there had been a loud bang. At the same time, the that comms were lost. I knew what happened. Sub imploded. I sent emails to everybody I know. I said, we've lost some friends. The sub has imploded. It's on the bottom in pieces right now. I sent that out Monday morning. I never believed in that technology of wound carbon fiber, wound filament, cylindrical hull. I thought it was a horrible idea.
So let's talk about that wound filament cylindrical hull. So this is a picture from OceanGate's website showing the hull. This is the actual compression chamber when it was being formed. So OceanGate also released this video of the carbon fiber hull winding as it was taking place. So there's the epoxy that's going on, and then they're going to show how it was wound. Now, as you can see, this is what we call a hoop method, and James Cameron didn't like this. He had specified in other interviews that he preferred, if you were going to do it this way, which he doesn't even like, but he would prefer like a diamond or some type of a mesh formation rather than just these straight lines. Okay, so one of my theories for the cause of this implosion of the Titan submersible would be this cyclic fatigue. And, you go down, you go up, and you go down 20 times. This submersible has made 20 trips so far. Your vessel is going to be compressing and decompressing and going like this, and eventually it's going to cause some kind of damage in there, some type of fatigue. And this is not a homogeneous material, you see. So there's really no way to detect the cracks. Okay, so now I have here a copy of this letter that was sent to Stockton Rush, and this was back in 2018. I'm telling you, this has more and more reverberations of the Champlain Towers collapse here in Miami, because 2018 is when the engineers there warned them at the Champlain Towers that it was going to collapse, and sure enough it did. But anyways, you can see here, one thing they're really worried about is right here. It says, our apprehension is that the current experimental approach adopted by OceanGate could result in negative outcomes from minor to catastrophic. Here's where it gets really scathing. Look at this third paragraph down. It says, your marketing material advertises that Titan design will meet or exceed the DNV safety standards, yet it does not appear that OceanGate has the intention of following these class rules. Your representation is at minimum misleading to the public and breaches an industry-wide professional code of conduct we all endeavor to uphold. That's probably one of the most damning statements I've seen against OceanGate so far. And it says here, however, we recommend that at a minimum you institute a prototype testing program that is reviewed and witnessed by DNV or ABS. Just like when you're building a bridge or something, when you're designing a bridge or a building, it's always a good idea to have a peer review, to have a third party check it out for you. So that's why they're saying here, it's our unanimous view that this validation process by a third party is a critical component to the safeguards. So the submersive vessel industry has been around for decades, and they've used tried and tested and certified materials. So the materials they prefer to use are steel, titanium, acrylic, and ceramic. And fiberglass has never really been one of them. When you look at the strength and the elasticity of these materials, so the modulus elasticity of glass fibers is about 72 gigapascals. The Young's modulus of steel is somewhere around 190 to 215 gigapascals. And then also, some of the expeditions were delayed in 2019 and 2020 after OceanGate was forced to rebuild the Titan's hull because it showed cyclic failure. One other theory that I subscribe to in relation to the possible root cause for the implosion of this Titan submarine would be that large 21-inch porthole. So let me show you what I found. What we're looking at here is a lawsuit between OceanGate and one of their former employees right here, David Lockridge. So he was sort of the whistleblower that came up with the quality control report that showed that there was something wrong with this vessel. So in his inspection report, it says right here, he identified numerous issues that posed serious safety concerns and offered corrective action and recommendations for each one of them. And one of them was the lack of non-destructive testing performed on the hull. Yeah, right here is another important paragraph where it says here that the visible flaws on the carbon end samples from Titan. So that's kind of interesting that he had found these things, and the constant pressure cycling weakens existing flaws, resulting in large tears of the carbon. So that's what he had written in his report. Here's the most shocking item that he found here. This is really what made my jaw drop. I gasped when I read this one here. Yeah, so in the media, meeting, he discovered why he had been denied access to the viewport. Yeah, the viewport at the forward of the submersible was only built to a certified pressure of 1,300 meters, although OceanGate intended to take passengers down to depths of 4,000 meters. So he learned that the viewport manufacturer would only certify to a depth of 1,300 meters due to the experimental design of this viewport supplied by OceanGate, which was out of the pressure vessels for human occupancy standards. So another non-standard item and not getting certified. The manufacturer is only certifying it up to 1,300 meters. He also told them to use the ABS or some other certification agency to certify this submersible. And then it says right here what happened. What was the response of the company? They gave him approximately 10 minutes to immediately clear out his desk and exit the premises. He was fired immediately. So it looks like they were trying to sweep this one here under the carpet. And of course, he was suing them for wrongful termination. So the other working theory that I'm looking at here in terms of the cause of the implosion of the Titan submersible here, the dissimilar materials that make up the three sections of the entire submarine. Now, you've seen me talk about this before here on the channel, where we talk about dissimilar metals and plumbing, and that's a bad thing, because when you have two different types of metals touching, that causes corrosion. And that's why you don't ever want to use a saddle valve for your refrigerator ice maker line, because a lot of people just clip it onto the copper pipe and screw it in, but the two different dissimilar metals can often lead to rust and it breaks off and then you have a leak. So let's take a look at why dissimilar materials here on the submarine might be a problem. Okay, so if we look at this drawing here of the Titan submarine, you can see here's our cylinder here. This is the part that's made out of fiberglass. Now you have a titanium cap on the back here. This is the cone, the end cap. And then on the front, you have the other titanium. And this is where the viewport is. This is your acrylic viewport. So now these all have an interface cap between the titanium front and the fiberglass. And there is another titanium cap right here. So what I'm saying here is that what if this fiberglass expands at a different rate than this titanium does? How do you mitigate that? This is why I prefer a homogeneous submarine. I'm willing to believe that if this submarine had been made out of the same material all the way around homogeneously, like steel or titanium, I think it may have survived, provided there was no problem with a porthole like I was showing you earlier. And this is what I found to be somewhat disturbing also. And this is a blog post that OceanGate put out back in February of 2019. And they were trying to justify here why we aren't classifying the Titan submarine. In the blog post, he's saying here, classing may be effective at filtering out unsatisfactory designers or builders, but the established standards do little to weed out subpar vessel operators. Because classing agencies only focus on validating the physical vessel, they do not ensure that the operators adhere to the processes. So this is kind of ironic here, because I think this is totally wrong. In fact, I think they fell into that category here of a subpar vessel operator. And here he goes. This is where they take an esoteric stance. This is almost like narcissism right here. It says here, by definition, innovation is outside of an already accepted system. So it's almost like they're saying, hey, we're better than the accepted standards, so we don't need to even be governed by them or certified by them. You know, hey, look at it this way. Every time Boeing and Lockheed come out with a new plane, there's all new technology in there, and they still get certified. But the OceanGate submersibles are the only known vessel to use real-time hull health monitoring. With this RTM system, we can determine if the hull is compromised well before situations become life-threatening and safely return to the surface. This innovative safety system is not currently covered by any agency. It seems to me like he's betting his entire lot of money on this, and I think this isn't really a very good idea. So what do you think of that idea? I don't think I like this idea. I think it sounds too much like an idiot light or something like Captain Obvious after the fact, saying, oh, you got a problem. This was me during college, okay, when my cars used to overheat and then the idiot light comes on. I don't think this system would give you any advance notice. I think it's going to be telling you right as it's happening, if it even works. Okay, so I went and checked out his patent for this technology, or this hull detect, and there you can see it. There's OceanGate up here in the upper left, and Richard Stockton Rush, that's his full name. I'm looking at his drawing here, and so what you can see here is, and I don't know how accurate this is to the actual implementation on the body, but he's showing these different types of sensors here. So he's got these acoustic emission detector on the interior locations here, these 20s. So wherever you see these round dotted lines, these are on the inside of the hull. Wherever you see these square ones right here, like here's one, there's one, here's another one here, another one here. These are the strain detectors. So the thing is, it looks like it's trying to listen for sound in cracks of strain, but that seems really hokey to me. This seems like something that would happen after the fact. Now, I don't know if you saw Dalmid's video. He uploaded this yesterday. He was supposed to be on expedition number 3 a few weeks ago. His mission got scrubbed because of failures, and I think also because of fog rolling in too. Let me just show you a little bit of his video.
They'll come back up, and then I think tomorrow we're heading off to the Titanic, and I am so excited.
Everybody was loaded in the sub, domes closed, everybody's ready to go. And one of the computers we've got, and one of them was acting up a little bit. It was offline. We decided to scrub the dive for today.
So it just didn't seem quite right, to put it bluntly, and that's why I called it. But mostly because we've got to find out what this control problem is. That's sort of important to controlling the sub. It's up there with life support. And so we'll be working tonight on that.
Boom. All right, so take a look. So there's a Titan submarine getting pulled alongside the ship. They're doing some maintenance right now on the Titan. They want to bring it alongside the ship. That's why they're doing that right now. There's the owner right there. He's going to put the buoys alongside on top so it doesn't get banged up. All right.
So he got some good video of that portal right there with a board.
Thank you.
Yeah.
Alright, we're inside the submarine right now. Got the owner right back there, stalking.
You just seen my bonnet.
Yeah. Keep in mind what you're looking at right now is the exact same submersible that imploded and killed 5 people. And also any footage you see of Stockton, of course, you know, he's passed away by now. If the fog didn't roll in and cancel the dive, who knows, maybe we would have left that platform and maybe we would have imploded. But I can tell you right now, I feel like I dodged the bullet.
Man, that was some pretty exciting stuff to see. So I'll put a link to his video down in the video description below for you. My very first engineering professor in college said to us on the very first day of engineering school that if you design a bridge that fails, you'd better be under it when it does. And this rang so eerily true here in this case. Now the question is do you think they felt anything when the implosion occurred? Now some of the experts say, well, they wouldn't even know that anything happened because it happens in a 20th of a second. You're gone just like that. The question is did that alarm go off and did they know that something was wrong? So I think they knew something was wrong. At least from what the reports say, they jettisoned the weight and were trying to come back up. And so it's possible they may have known something was wrong, and they also knew that they didn't have contact with above. Now, do you think maybe they heard some creaking noises like other passengers reported on previous dives? I think that's possible too. So you have two theories here. Either they heard their alarm and they were acting on it and trying to get back up, or they didn't really know that anything was going on and the implosion just went poof, just like that and killed them instantly. Man, I sure hope it was the second one because, man, the panic they must have been under would be incredible. So this is what I want to know is when are people going to learn and when are they going to listen to the common sense, to the red flags that come up, to the warning flags? This has so many parallels, not only just to the Titanic itself going down. Remember Captain Smith, he sped up and went right through that iceberg field anyway? They didn't care.
Sandbags are west of us. I'm headed east. The Plymouth Cat. Oh, you know, why don't we steam to Portugal while we're at it?
This also has other parallels, as I mentioned before, to the Champlain Towers collapse in Miami, and also to that Davenport apartment collapse that just happened last month, where we lost 3 people in that one as well, because they had plenty of warnings to the owner of that building, and they didn't listen either. I think history is just going to continuously repeat itself, because that's human nature, folks. I don't see this getting any better anytime soon. Well, I hope this helps bring closure for you and helps point your brain in the right direction in some areas that you weren't thinking of before, what could have caused this implosion of the Titan submersible. So thank you so much for joining us today, folks, and we'll see all of you on the next one.